So welcome to Quantum Online Academy. This is your Dr. Nagaraju Pendem. Today I want to introduce about the BSC Electronics Paper 5 exam strategy. So in college, so many people are asking, so what are the important questions? Please tell me, sir, like that they are asking. If I make the video and I will upload in the YouTube, entire the Telangana state will listen. So that's why I'm doing this one. Please subscribe my channel and share to your friends. Now we have to go to the electronics 5th semester. What is the syllabus is there, how the expected questions will come in your theory examination, we will see, right? Now we will see in BSc third year semester 5, that paper title is digital electronics. Among all the papers, this digital electronics paper is very simple paper. Maybe children will like this paper is a very easy way, because these all the concepts are very simple concepts are there. So what is the syllabus? Once you have to check the syllabus, digital electronics syllabus. Unit number 1 consists of 2 parts. One is number system, another one is logic gates. In number system, the syllabus contains conversion of binary, that base is 2, octal, that base is 8, right, decimal, that base is 10, hexadecimal, that base is 16, number systems. So you have to convert decimal to octal, octal to decimal, decimal to binary, binary to decimal, decimal to hexadecimal, hexadecimal to decimal, or binary to hexadecimal, binary to you have to convert. So that conversion is the first topic. It is very important and easy. Every computer is based on the hexadecimal system. Binary addition, binary subtraction, ones complement and twos complements method. So this is the number system. Very simple. Maybe in degree first year also ACC paper is there. In that paper also people will learn this unit number 1 by number system. Now the second one is the logic gates. Here basic logic gates are there. What are the basic logic gates? You have to see OR gate and AND gate and NOT gate. These 3 gates are the basic logic gates. And XOR gate, NAND gate and NOR gates. So NAND gate and NOR gates are the universal gates. To construct the basic logic gates, we have to follow this NAND gate and NOR gates. These gates we call it as a universal gates and their truth tables, and they design the basic gates using the universal gates. The universal gates are NAND gate and NOR gates. Off order, full adder and parallel adder, 3 adder logic circuits are there, and logic families and their characteristics. So TTL, CMOS and ECL. So these techniques, transistor logic circuits and complementary metal oxide semiconductor logic circuits, electrode circuit logic circuit is there. So these logic circuits is there according to your syllabus, right? So those number system and logic gates are there. These logic gates you have to see. What are the expected questions? Each and every unit 8 questions I gave. Only 8 into 4 units are there. So 32. You will get the 32. If you read the 32 questions, you will get 100 by 100 marks pakka. Okay. So you have to go for a textbook or whatever it may be. Maybe in the next semester for onwards, I have to upload all the lessons in YouTube. You have to listen my classes and you read in your exam and you write in your exam. That will be helpful in your examination also. First short questions you have to see. What is ones complement and twos complement? This is very important. Suppose one number you have to take 1001. So you have to add it 1. Ones complement you have to get it. Ones complement zeros, ones you have to convert into the zeros you have to convert into the ones. You will get the ones complement. So you have to add this number, 1's complement for this number, 2's complement it will come. So this 1's complement and 2's complement is important for short question. Convert the 37 is a decimal number. 37 is the decimal number. So base is 10. So you have to convert into the hexadecimal number. Hexadecimal number is 60. You have to convert it. How we have to convert? So you have to explain that. So then you will get the problems you will get in a short question or long question also. 4-5 questions they will add. Then they will ask as a long question also. Explain about the CMOS technology, complementary metal oxide semiconducting technology for logic circuit. So that technology you have to explain. TTL technology, CMOS technology, ECL technology, whatever the technology is there, that technology you have to use. Next, what are the universal gates? What are the universal gates? NAND gate and NOR gates are the universal gates. Why these gates are universal gates? You can construct by using these gates any gate, any basic gates or any gates. You have to construct from these gates. That's why these gates we call it as a universal gates. Clear? So these are the short questions. Short questions will come like that. Long questions you have to see. Discuss about the number systems. What are the number systems are there? Binary number system, decimal number system, octal number system, hexadecimal number systems are there. No? So those number systems you have to explain. Discuss about the logic gates. So what are the logic gates are there? AND gate, OR gate, NOT gate, NOR gate, NAND gate, XOR gate, XNOR gate, like that. So all the logic gates you have to explain. Explain about the off order, full order and parallel order. These are the orders. So you have to construct the diagram and you have to draw the truth table and you have to draw the logic circuit also. So you explain that. Explain about the TTL and ECL circuit, logic circuits. So these 4 plus 4 long questions and 4 short questions you have to read from unit number 1. Now we will see unit number 2. What is the unit number 2? This is the Boolean algebra unit. This is very, very simple. Maybe the Chinese scientist Boole introduced this algebra. That algebra we call it as a Boolean algebra. Clear? So now you have to see Boolean algebra laws. So Boolean algebra laws are there. What are the laws? NOT gate laws are there. AND gate laws are there. NAND AND gate laws are there. OR gate laws are there. These laws you have to take. Laws of the Boolean and identities. De Morgan theorem. This is very, very important. This theorem will come. Pakka it will come. De Morgan theorem. 2 theorems are there. The complementary of their product is equal to sum of their product. Product of their complement is equal to sum of their products. That is the De Morgan theorem. Simplification of the Boolean expression by using the Boolean identities. Reduction of the Boolean expression by using the K-map. That is the Karnaugh map. The 2 ways are there. Sum of product form and product of sum form. Sum of product form and product of sum form up to the 4 variables. You have to use 8 variables also. According to your syllabus, up to the 4 variables only. Combinational logic circuit. Combinational logic circuit you have to see multiplexer, demultiplexer, decoder and encoder. So 3 to 8 and 8 to 3. So order is there. How decoder 3 to 8 and 8 to 3 encode it. According to your syllabus. 2 parts are there. One is Boolean algebra. Another one is a combinational logic circuit. Now you able to see 4 questions I gave. Short questions. Define the De Morgan's theorem. De Morgan 2 theorems are there. A dot B whole complement is equal to A complement plus B complement. So A plus B whole complement is equal to A complement into B complement. These are the 2 De Morgan theorems. So these 2 De Morgan theorems you have to prove by using the logic gates also. Next, A plus AB is equal to how much? So you have to take A common, 1 plus B, 1 plus anything is equal to 1. So A into 1 is equal to A. So like that you have to do simplification of the Boolean expressions, right? By using the Boolean theorem, we have to do like that. Distinguish between the sum of product and product of sum. In sum of product, you have to take it as a 1. In product of sum, you have to take it as a 0. Min terms, max terms and all those things you have to write it. 3 variable K-map and 4 variable K-map you have to you have to distinguish these sum product and product of sum forms. Next question is distinguish between the mux multiplexer and demux demultiplexer. What is the mux? What is the D? How many inputs are there? How many outputs are there? How we have to change? How many selection lines we have to use? Based on the selection line, how we have to identify the output? That one we have to take from multiplexer and demultiplexer. The long questions you have to see. Discuss about the Boolean algebra. Boolean laws you have to write. Simplification of the Boolean theorem you have to write from this. Discuss about the Karnaugh map. In K map you have to write the sum of product and product of sum form. 3 variable K map and 4 variable K map you have to take. How we have to write the K map? Suppose if you have to take EAB, here you have to take, and so if you have to take the AB and CD if you have to take here. So now this is a 4 variable K map it will come, because so AB is equal to 0, 0, 0, 0, like that you have to take 4 variable K map it will come. So how we have to use the 4 variable K map? You have to write like this. AB and so CD, AB and CD you have to take from this 4 variable K map and 3 variable K map. Any variable K map also you have to do. So that is the K map one. By using sum of product and product of sum forms you have to take from this. Explain about the mux and demux. Explain about the decoder and encoder. So these are the long questions. Very simple. Within 1 hour we have to learn all these things. Already you have idea about these questions also. Right. Now this is very interesting unit. This is the third unit. Digital electronics third unit. Sequential logic circuits and counters are there. In sequential logic circuit, flip-flop is there. Flip-flop is a very important flip-flop to make the microprocessor and microcontroller. So each and every flip-flop can act as a resistor. So this resistor we are using as a memory element, right? Each and every flip-flop, one memory, one bit it can act as a memory, 1 bit memory. SR flip-flop, D flip-flop, JK flip-flop, T flip-flop and master-slave flip-flops are there. Master-slave, JK flip-flop, right? So how many flip-flops are there according to your syllabus? One is SR flip-flop, not SR latch, SR flip-flop, transparent flip-flop or data flip-flop, JK flip-flop, toggle flip-flop, master-slave, JK tip flip-flops. So this one is a flip-flop. This is a bistable element. Next, resistors. Shift resistors are there. In the shift resistor, serial in, serial out, serial in, parallel out, parallel in, serial out, parallel in, parallel out resistors are there. 4 types of shift resistors are there. Only 2 questions are there in sequential logic circuit. One is the flip-flop, another one is the resistor. Next, counter. 4-bit asynchronous counter. That asynchronous counter is a ripple counter. Modulo N counter. Synchronous counter, up and down synchronous counter you have to take ripple counter, IC 7493, decade counter IC 7490, working truth table and timing diagrams. These synchronous and asynchronous, 2 different varieties of counters are there. One is synchronous counter, another one is asynchronous counter. So their counters, truth tables and time diagram, time period diagram and their frequencies you have to learn from third unit. How the questions will come you have to see. Discuss about the SR flip-flop. Very important. Maybe in further education also it will be useful. SR flip-flop. Discuss about the shift resistor. So shift resistor, if you have to give the pulse automatically. So right shift resistor and left shift resistor is there. Universal shift resistor also is there. Those things you have to explain from here. Next, explain about the ripple counter. So ripple counter, in synchronous ripple counter, asynchronous ripple counter also is there. You have to explain any one. Distinguish between the synchronous and asynchronous counter. Based on the clock, so you will get the each and every resistor will get 1 clock, and only 1 clock you have to use for all that. So based on the clock only, we will distinguish between the synchronous counter and asynchronous counter. Explain about the JK flip-flop and master slave flip-flop. JK flip-flop, one toggle condition is there. So toggle condition 0, it can become as a 1, 1 it can become as a 0. To eliminate this toggle condition, we have to use a master slave JK. Master is you have to use slave as a JK, you have to take master slave JK flip-flop. You have to explain by those two things. A long question it will come. Truth table and how it works, everything you have to do. Explain about the serial in, serial out, serial in, parallel out, parallel in, serial out, parallel in, parallel out shift register. Explain about the synchronous up and down counters you have to explain. Explain about the decoder IC7490. So these many questions you will get in your theory examination as a long questions and short question. Now you are able to see unit number 4. What is the unit number 4? It is very, very important. Unit number 4 is a microprocessor. This one is microprocessor is the first generation, second generation microprocessor 8085. This one is second generation microprocessor. Now we are not using the processors, we are using microcontroller and system, embedded system, many advantage ICs, so many advantages came, even though we are learning from this. So now you have to see introduction to 8085 microprocessor and its architecture. Architecture of 8085 microprocessor, there is CPU, timing and control units are there. So these units you have to explain. Instruction cycles, fetch cycle, executive cycle, timing diagram, mission cycle, clock states, interrupts, hardware and software of the microprocessor, address space, partition memory, mapped input and output, mapped input also you have to learn. Next, instruction sets of microprocessor. To write the program of the microprocessor, we have to follow the instruction set. So those instructions only we have to give the microprocessor kit, then only microprocessor kit should work, right? So that kits you have to learn. Instruction of 8085 microprocessor. Classification, data transfer operations, arithmetic operations, logical operations, branch control operation, stack, input and output mission control operations, stack and subroutines, addressing modes. These are instruction sets you have to learn. Next, how we have to expect the questions from unit number 4. Once you have to see, explain about the instruction cycles, fetch cycle, executive cycle. This question will come as a all cycles you have to learn, whether it may be long question or short question you are able to get. Explain about the interrupts. So many interrupts are there. So those interrupts you have to learn from here. Next, explain about the addressing mode. Addressing modes also very, very important. Addressing modes of 8085 microprocessor you have to explain about. What is the stack and subroutine? You have to explain for what is the stack and what is the subroutine and what is the addressing mode. You have to explain that. Next, long mode questions. Draw and explain about the architecture of 8085 microprocessor. You must read this question. This question compulsory will come in your competitive exam. You have to draw the circuit diagram and you have to draw the neat diagram. There you have to write CPU, control system, timing system, everything you have to explain. Where is the memory, where is the flag, where is the stack, where is the address bus. Everything you have to explain. That is very, very interesting question. This is the basic and fundamental question only. Write about the hardware and software of 8085 microprocessor. Classify the operations of 8085 microprocessor and explain about the instruction set of 8085 microprocessor. To add, to subtract, to multiply, to divide. We have to use this to give the data. We have to give some codes. Those codes you have to learn. The op codes also you have to learn. How many op codes are there in 8085 microprocessor? What is the input we have to give? What is the binary data? What is the ROM? What is the ROM? Everything you have to learn from this microprocessor. It is very, very important. What are the reference books to follow the 8085 microprocessor? Digital Principles and Application for first one. Melvino Leach. This book is very, very important and costly only, but based on your teacher, based on your, so that number system and logic circuits is very, very easy. Any book you have to follow, not necessary, but this book is very nice. Digital Principle and Application, Ronald J. Toki, Pearson edition. Textbook of Electronics, BSC 3, Telugu Academy also you have to follow. Digital Fundamentals, Floyd and Jain, Pearson publication. Fundamentals of Digital Circuit, Anand Kumar. So Digital Electronics Principles and Integrated Circuits, Digital Electronics, so Unified Electronics Volume 3 also you have to follow, or 8085 microprocessor RAM you have to follow, right? Another name is there, that is the Muhammad, that book also you have to follow. Whatever it may be, my 8085 RAM also you have to take, that one also very, very nice. So these books you have to take for each and every unit, we have to follow which different book. That's why you have to take the digital fundamentals of digital circuits or textbook of electronics BSc 3 from Telugu Academy, or Unified Electronics Volume 3 from Unified books. These two books you have to take, or one book you have to take, you will get the entire portion from the entire portion was covered by this book. Thank you. So please share my video and subscribe my channel and share to your friends. Thank you for listening, your patience.